break-even analysis. So here we're going to look at two straight line graphs, and one's going to be for cost, one's going to be for revenue, and we're going to hopefully be able to see where the break-even point lies. So let's give a bit of information on an example. So we have a business with a fixed cost of $200 per day, and they sell burgers that cost $5 each to produce. That's part of their cost, and they sell them for $7 each. Let's have a look at a graph that shows this information. Okay. So on our y-axis, we're going to have everything in terms of dollars. And on our x-axis, we're going to be talking about burgers. Okay. This graph was given, so we're showing the cost first. Marker at 200, one at 400, and 600, at 800, we've got a straight line here, and this is our cost. Now, our revenue is here because if we sell no burgers, we're not making any money. When we sell 40 burgers, we're actually making $300. When we sell 80, we're making $600. When we sell 120, we're making $900. When we sell 160, we're making $1,200. And we get another straight line. And that's our revenue. Okay. Now we should be able to answer a few questions. So, how many burgers does it take for us to break even? Well, the break even point is where the two lines intersect, because that's where our cost equals our revenue, and we're not making any profit there. We're not making any profit there. So that's always our break even point. And for our break even point, we need to sell 80 burgers. Okay. And what's the revenue at the break even point? Well, that's $600. Which means we're bringing in $600, or the company's bringing in $600, and it's also costing them $600 as well, so they're not making any money at that point. So what's the profit when 160 burgers are sold? So we can go to 160. You can see it's costing us $1,000, but we're bringing in $1,200. So our profit is going to be $1,200 minus 1,000, which gives us a profit of $200 when we sell 160 burgers. Now, can we determine the equations for the cost and the revenue? Yeah, we can. So let's have a look. So we know any straight line has the equation y equals mx plus c, where m is the gradient and c is the y-intercept. So for our cost, well, in this case, so we'll go big C for y, because this is going to be C or R, because it's cost or revenue. and our y-axis we can use B for X for burgers. So our cost is going to equal our gradient of the cost line, which the gradient, it's going up 200. It's going up 200 here for every 40 we go across. So that's our rise over our run. So our gradient is going to be 200 over 40 times X, in this case it's B, plus our y-intercept, and our y-intercept is over here of 200. And then 200 divided by 40 gives us 5, B plus 200. And it makes sense that it's 5 because the burgers, remember, cost $5 to produce. So it makes sense that that number there is also 5. Now what about our revenue? So again, that's in the same form, y equals mx plus c. So we use r this time for y, and we need the gradient of that line. And this time, it's going up 300 for every 40 that it goes across. So up 300, 40 across, up 300, 40 across, so that's our gradient. So that's 300, 300 over 40 times b, plus our y-intercept. Well, our y-intercept in this case is 0 because it's going through the origin there. That makes sense because if you don't sell any burgers, you're not going to make any money. So there is no y-intercept. And we can just tidy this up a little bit. So 300 divided by 40 gives us 7.5b, and that's our equation for revenue.